Hi there. So I'm going to give a talk. It's not as rigorous. Heavy disclaimer, it's not as... Heavy disclaimer, this is not going to be as rigorous as any of the talks that you saw yesterday or the day before. This is like a bunch of random thoughts of mine because I've been in this ecosystem too long and I've been observing various things. And I hang out with Victor, Aaron, and the rest of the crew and observe what's happening and have a lot of interest in cryptoeconomics. And it so happens that I've been involved in the initial cloudy evolution. So I was involved in writing up initial standards, the guides, and sat on the ISO committees, and saw how Amazon evolved. And okay, things are happening. I don't know what's happening. So I thought, you know what, I'll try summarize what my observations are and what I see the trade-offs are. And I'm coming from a very crypto end of things, as in like cryptoanalytical, cryptography, that kind of thing. That's my background. So forgive me if I say something which is not in your context. Stop me. I'll try to explain as best as I could. Okay? So I'm assuming everybody has a fair understanding of most of the crypto primitives. And that's my assumption. And I tried yesterday night, after our dinner, putting my thoughts on the slides. So the slides are not the most coherent, but here you go. Before I start, who here hasn't heard about cryptoeconomics? Ah, good. Very good. All right, okay. So this is essentially the definition. This is, I'm quoting Blab, so this is what he said as to, what the definition should be. I think the thing I found most interesting is this. No, this bit, okay? I took this from Wikipedia, right? And the thing that it describes is a social science concerned chiefly with description, analysis of production, distribution, and consumption of goods and services, okay? Look at that. And it's quite interesting. It's just a flipping of the world's model of how we are observing things and how we are actually going to evaluate value of things and how we're going to manage supply and demand. My thesis in this whole talk is like, data, as everybody knows and I think Chris Anderson came up with this thing about the new oil and shit like that. Sorry, whatever that is, right? So I'm going to, show the thesis, and I'm going to say to you that finding a value of data is not really hard. And actually having models describing attackers and defending yourselves for any set of data is pretty hard. And having actors defined and having defined definitions of half-life of data is even more harder. So I'm just going to throw out a whole bunch of things and kind of ask a lot of open questions. So it's no answers to any of these questions. Suggestions, and I am willing and open to be challenged, because I just want people to think about it slightly differently, because this is not a solved problem. The way we are currently looking at data and the way we are actually trying to evaluate it and the way we are trying to offer services to store it is probably not the best model going forward, given the change in the set of actors and the way the world is working. So, cryptography, obviously. I mean, I like it. I spent a lot of my life doing this shit. Now it's become in fashion, and when I started out, it wasn't any fashion. So, and as I described, this is economics, right? And I want to take you back a bit and kind of show this. Why do I show this? Normally, the utility function of anything is never found in the early part of this thing, right? And who in this audience would agree we are towards the left rather than towards the right? Okay. So this is like a pretty interesting scenario, because like right now, a lot of the things that we are thinking is because of this, right? And I would pretty much put my hand on my heart and say, I am pretty sure probably here is where we are. And mostly it's here. The community in this room is pretty much here. And if you're lucky, I would say here. That's the mix, right? So we are making assumptions about this whole, whole sigma, right? The whole distribution. And that's actually causing us some challenges. And this actually causes the real problem for us, okay? Because like we are making assumptions about an average person on the street. And we are making protocols that we assume an average person on the street. If you remember some of the conversations yesterday we had a talk by somebody describing how to create streaming of value. we are making strong assumptions about behavior, user behavior. It's behavioral economics. And that to me is a bit worrying. It's like, a geek like me who spent a lot of time in math departments turning up and trying to, at least attempting to model user behavior and making assumptions, very strong assumptions about not just things. Data is one of the real fundamental milestones of civilization as we are going forward. And that is pretty important for everybody to understand. And this is Simon Wadley's mapping exercise. He kind of describes this way. And he was very, very influential in the initial cloud ecosystem. And he kind of described how this adoption happens and the real, when something turns up in the genesis and it's custom built. Take the case of electricity, right? When we actually had Edison versus Tesla, they actually had their own generators and they had to have transformers to Edison doesn't have transformers because it was DC, right? Tesla had the possibility of having transformers, right? And they didn't have standardized plugs. We reached utility. You just go plug your thing onto the wire, you get electricity, whether it's 110 volt or 220 volts, so many cycles, and you know what the cost of that. And that's why we have mining and all the shit that's happening. We have all these devices, right? And this is essentially what will happen to data. At some point in time, we would actually know what the value for data is and what is it that we are willing to, what's the definition of the socket? Okay, how does that, some of these things already exist. And I'm going to go to that in a slightly different way. I'm going sideways, okay? So it's like I'm looking at existing models and working backwards on what is it that we can learn from what other people have learned. Okay, what Amazon has done, we need to understand this from a historical context. When they turned up and started up EC2, they had no SLAs. You only had like a Linux console that you can run, and they had nothing, okay? You could log in, and I used Kimu to run a Windows 2003 instance on top of it. Okay, that's because I wanted to do that. But there was nothing. There was no SLAs, no identity and access management, no logging, no nothing. They didn't have pricing for any of these things, okay? They discovered price. And this is a reflection of their monopoly in that sense, almost a monopoly, right? If you look at the total distribution of cloud in the world, the fraction that Amazon represents is massive, okay? This is, it's not a fair market, as I would put it, but this actually indicates to you what people are willing to pay as a price right now. Am I making sense? So, if you were to build a protocol, you need to have indicators. So you know where you can draw a line. Like, okay, this is the realistic line that's happening. Beyond that, if I try, my ability to compete is kind of compromised, right? I turn up and go, I want to compete with something that's available, same price, pretty good, same spec, more expensive unless some branding of some sort. It's pretty hard to, the only thing that really seems to work, which really defeats normal thinking, is Coca-Cola and Pepsi. It's sugar water. I still wonder, I know dopaminergic centers in the brain will be triggered if you take sugar, that works, but in a normal sense, that's tricky. It's like water in a particular bottle, cost differential, massive. Things like that had happened in the market, but not the norm. So, I'm kind of giving you what the price of water is in that sense, okay? I'm not saying we should actually sell Coke and Pepsi and use that model, but I'm saying, we need to think about water being bottled and water being available to people, because this is water. Okay, so look at S3 and the way they actually, price it, right? Pricing generally, essentially for data, is like a three-way function. I was kind of talking to, I forget his name now. He was talking about Swear and Swindle yesterday. So it's a three-way function. He's just right over there. So it's, you have a trade-off between network bandwidth, I/O, as in network bandwidth in that sense, storage, plus CPU. So you have a three-way, you could have a thing like that. It's a volume under a curve rather than an area under a curve. Am I making sense? So if you have an expansion function, it could be possible that your data could be compressed, right? And the entropy for that is much higher. And similarly, if the bandwidth is that, it might make sense to not encode, for example. I'm just giving you random examples. So these are trade-offs. These are trade-offs that we currently are not really leveraging in our cryptoeconomic protocols that we currently have. We assume one or the other, okay? Just giving you intuitions. Okay, and the other thing I wanted to describe is, is not my idea. I've observed this in enterprises, but other people have wrote a book about it. And Oracle and people who sell large databases actually have done a reasonable amount of research. There are a couple of pieces of research that you can find. This guy wrote a book. Effectively, like all things, data does have a half-life. And there's another thing I want to mention this to you, because like one of the things I am very passionate about, and probably a lot of these people in this room are passionate about, is privacy, okay? So data, people's data, will have some sort of a life, okay? So if you look at classification of data, I'm sure you are all aware of, different countries actually classify data set, as in like, say this is classified, so they won't reveal it to anybody other than the people who have the clearances, okay? At some certain point in time, they will reveal it, okay? So similarly, people's data will have kind of a lifespan, okay? And enterprises' data will have a half-life. So to me, I think most of what we will be aiming at, the largest set of data, I think, will be more people like you and me data, rather than the enterprise data set. That's one of my core assumptions, because like otherwise this game would be very skewed, because the economic incentives for actually enterprises to store data in a very open network is very different from actually people like you and me doing that, because of a lot of legal obligations and other obligations they actually have. Okay, and one other thing I thought I should mention, because like it's kind of important to set context. So whenever I've been talking about protocols and cryptoeconomics, I am basing this on the framework that any of the tokens that we're actually going to have to use to build such a protocol is a utility token. And I'm going to redefine what a utility token really means from a very cryptoeconomic perspective, okay? The reason I say that is like if you have, in an arbitrary sense, gold being tokenized, right? You have no ability to control the value of gold in the market by trying to manage the supply and demand of the tokens that it represents. You absolutely have no idea, no ability. So it doesn't work. You have no control. For a utility to really work and you want to be able to have the right kind of behaviors in an ecosystem, what you need to have is the ability to control your supply and demand using cryptoeconomic tools or levers. And to me, that would actually define a utility. And to me, data storage is a good example of that. And what I'm saying, again, is pretty important. I should, again, highlight this. The thing I'm kind of highlighting is like if there is a behavior where this particular token is going to represent some sort of store of value for, not really store of value, an investment opportunity for any set of people, then our ability to actually have the utility behavior will disappear pretty much straight away. Then it's arbitrage over time. That's pretty much what's going to happen. So we need to actually think about this. We need to actually think about inflationary characteristics of tokens. I'll repeat it again, inflationary characteristics of tokens. I know this is antithetical to what most people are thinking about, but I think we need to start thinking about things slightly differently. If you really want to build an infrastructure that's going to actually serve everybody, we need to really start thinking differently. Okay, this is like somebody else's question there. I tweaked it a bit to help people understand what it is. But I'll just go through that. Everybody here would know about Union Square Ventures, right? Is there anybody here who doesn't know about Union Square Ventures? Okay, good. So, these guys said this. Protocol goes faster than the combined value application and the thing. And it's pretty important. It's very important in a very important sense. Look at the value of Facebook. Look at the value of Google. What's the value of TCP/IP as it is what we know? Right? Interesting, right? And this is what is happening. And it is a very interesting implication. So look at this, right? I'm being a devil in that sense. It's like I'm questioning ourselves, right? One of the things we need to understand is like when we actually want to have price discovery, if we have smart contracts to actually do price discovery, this is an old one. I haven't updated it. So I have a very strong disclaimer. Okay, ETH value is not today's, but you can look gas required and you can look at it this way, right? So that is what it is. And it's not really good for us to actually have large amounts of code doing anything. So we need to actually think about a way by which we can actually do our logic somewhere fast enough, again, okay, fast enough and cheap enough. Okay? If it's not fast and if it's not cheap, the price discovery for small value is not going to happen. Am I making sense? Yeah. So this is a very important thing. So right now, in a sense, if you're being a deep skeptic and willing to look at the mirror and say, I'm not going to talk bullshit, you might say, we have a challenge of not having enough of a protocol that can do this for us. If we want to really have the data that we really use on a day-to-day basis, not being given to a set of people that causes so much trouble, as we saw recently, right? And if you want to provide privacy to average people on the street, and we have a massive adversarial problem, and I will go to it in a minute. Okay, this is like, ignore it, okay. Yeah, okay, security margin of proof. But the thing I really want to say is like, this is a bit geeky. This is from a paper that is published. There's no recent updates to this paper. Nobody has actually published a paper looking at the security margins for various things, okay? Eric Warhol and Arjun Lenistra published this paper 2001, and this pretty much remains to be like the yardstick, but it's, things have moved on, lots of things have changed. Again, the reason I'm mentioning this is like a lot of the assumptions that we make about security margins are pretty interesting, okay? This is kind of what it looks like. So I think we are here. Things have moved on quite a lot, right? So it's the year symmetric key, the asymmetric classic STL, ECC. ECC, again, in a sense, like is more prime P rather than anything else. And like MRPS year, that's like the cost. And look there, it's like Pentium 2. I don't think half the population in this room wouldn't even recognize what that is, right? So, look at it there, yeah. So, this is from the old days, but this is what gives you an intuition about the security margins we actually have, right? And we need to understand this in a slightly different way as well, right? You could also look at it by looking at assumptions and progress, okay? And then you can do a finger in the air estimates of, okay, where things are going to be. And I will tell you why I'm saying all this, okay? Right, I need to show you this, okay? This is what I wanted to show you, and then I'll work backwards. So our current assumptions is there are no existing QCs that have the ability to have probably more than, say, 50 qubits. Okay, I'm not talking about D-Wave. I'm talking about traditional quantum computing, not adiabatic compute, okay? So we can actually do Shor's algorithm, right? So that's an assumption that hasn't been factored into the previous thing that was there. Imagine our situation being, like 5 years, okay, say 10 years, like a pessimistic view, that 10 years time we will have a QC that's capable of actually doing anything real, right? Even then, we haven't really looked at our protocols in a way that we could swap out our parameters to plug in new ones. And we haven't factored in security margins the way we should look. And I'll give you one more reason why we should think about it that way. Okay, this is like my thinking about what we should do, but ignore it, as people have been looking at it. If you look at the proceedings of post-quantum crypto, you can see that. But again, you should understand, from 2008 to 2016, there was no proceedings. It was a dead topic for almost 8 years, okay? Nobody was interested in that. So we need, I need to shut it down as soon as possible. Okay, so this is it, and I was kind of describing one small bit. So one of the things I want to say was like, sometimes some of the problems could be actually solved by actually introducing intermediaries. And intermediaries, if we could actually do it in an efficient manner, it might be possible for us to gain increase in elasticity and possibility of getting price discovery. And I'm kind of proposing that we should think about reinsuranceing, because that's how traditional markets work, right? And I also wanted to mention attacker models like nation state, right? Pretty important. If you look at Cambridge Analytica and the rest of the guys, what we are understanding is nation state have interest in actually having data and changing the validity of it.